Welcome to this focus tutorial on how to create a melee combat system with free visual game engine Gdevelop. Let's start by taking a look at what we have done in the previous episode. We can basically kill any enemy with our sword, as soon as they are in range. But the enemies that are coming with the Gdevelop platformer tutorial are killing us by contact and are not actually trying to make damage. In this second and last part of the melee combat system, an enemy able to hit us too with some type of sword. In our case, we will be using the skeleton enemy that has a spear axe weapon. Remember that this is an intermediary tutorial, so we will not comment on all the steps of the process but only the most important ones. Let's start the fun. First, let's create the enemy logic. For that we will be using the same mechanism used with the player, splitting the enemy movement and logic from the enemy's animation. For this, we need to create a new sprite object and name it physic enemy. Add an animation, and with Piskel create a square with any color you may want. In our case, purple. Then add the platformer character behavior, and in the options, disable the default control option. Fine-tune the parameters as it suits you the best. Drag the physic enemy object into the scene view. Now, let's create the object that will hold the animations of the enemy. Create a new sprite and name it skeleton enemy or any other name that suits your case. Add all the animations that we are going to need. Idle, walk, hit, and finally attack. Once the animations are created, load from the hard drive the different sprite sheets for each of the animations. Click the loop checkbox where appropriated, in our case, only idle and walk. Once all animations are loaded, we need to adjust the origin of the sprites to place it consistently across all the sprites used. In our case, we are placing it at the bottom center of the slides. If you are using the same skeleton character as us, then you will see that the skeleton attack has a different format of the sprite. This means that we cannot use the option to share all the points throughout all the animations. Uncheck it, and leave activated the option Share Same Points for all sprites of this animation. Adjust carefully the origin of each animation, or you will face some jittering of the sprite position. Once the origin is correctly set, we need to change the default collision for the sprites, to make it specific to the character and not to the image itself. So choose the option Use Custom Collision Mask. Adjust the points for the collision as to cover the portion of the character you think can be hit. The same problem of the different sprite sizes applies here, so be sure to unselect the option Share Same Collision Mask for all animations. Once finished, drag the skeleton sprite to the scene view. Scale it, and if you have set correctly the properties of the project, it should resized without losing quality due to the internal smoothing feature of Gdevelop. If it loses quality, then remember that you can switch off the smoothing used by Gdevelop under the Project Manager, Game Settings, Resources option. Let's move the enemy to where we can actually interact with it, because, at this moment, we have put it outside of the borders of our mini-level, depicted by the red blocks. We need now to code the main behavior for our enemy, and since it will have a different set of mechanics than the current enemies, let's create a new external event that will be used to hold the events associated with this new type of enemies with weapons. We may be having a naming creativity crisis, so, we will name it Animated Enemies Management, but you can call them any name we want. Associate it to the main scene. Instead of starting from blank, let's take some advantage of the existing Enemies Management external event, and let's copy all the events into the new event sheet. We will then modify it to suit the parameters of the new type of enemy. Before starting to make the changes, we need to create a new group that we will call Animated Enemies and to which we will include the physic enemy object. We also need to replicate some of the variables currently being used by the event associated with the enemy objects. So in physic enemy, let's add an object variable going left, that we will initialize with the value 0. Once done, let's go back to the Animated Enemies Management event sheet, and let's start to replace some of the references with the new elements. So, let's replace the enemy group for Animated Enemy. Let's change the references from the Fly Enemy to Animated Enemy 2. Once done, we need to include the event into the main loop for the game, so we will have to add it to the main event sheet, below the link to the already existing enemy management event sheet. For that, from the Add button on the top bar, add a new comment to explain the purpose of the change, and then add a new link. Click on the link and select the new event sheet Animated Enemy Management. Let's make a quick check on what is happening at this stage with the game. Remember that it is always very important to test changes as frequently as possible, and preferably in small incremental steps to make it easier to find bugs or to revert changes in case something breaks. Well, nothing is happening. The skeleton enemy is just hanging in the air in the idle state without doing too much. Let's go back to the events. The problem is related to the fact that the enemy, now, will move based on simulating the controls press, but in the current movement function, we are trying to add a force in a way that will not work with the platformer character behavior. So, delete the actions associated with adding a force when the variable going left takes a new value. We need also to make sure that we are flipping the enemy sprite, because currently what is being flipped is the physic enemy. Since now, we also have different sets of animations, let's make the enemy change the animation to walk. Finally, for each frame, let's make the position of the animated sprite to take the position of the physic enemy behavior. Let's try it. The enemy is moving back and forth with the right animations, but it is getting the flips wrong. The flip events need to be fine-tuned to make them work correctly. Let's try it again. And the skeleton is moving nicely between the two waypoints. Maybe he is going slightly fast, but it is a simple question of adjusting the parameters for the platformer character behavior. A slight problem that we have, is that at then beginning for the event sheet, we are disabling the platformer character, so let's activate it again. Now, we need a way for the enemy to detect the player. In the Contras series we are using raycasts, but in this solution, as to be able to show a broader range of possible solutions, we are going to use the collider on an image, that when intersecting the collider of another object, will trigger specific functions associated with detecting the player. Let's call it enemy vision. And in Piscal draw an arrow, or any other symbol that can help you depict that it is the direction where the player is turned toward to. Drag the new object into the scene view and size it up as to fill more or less the space intended for the detection of the player. At the beginning of the scene, let's initialize the direction it is facing. We also need to move it with the player to be able to detect constantly enemies along the path. So below the action where the position of the player sprite is updated to the one of the player physic, let's add a new one to move this new game object accordingly to the position of the physic player. We need also to edit the sprite image's points as to have it correctly positioned and orientated toward the direction the enemy is moving. In this case, we are not choosing the bottom center, but rather set it to the bottom right. Later on we will also change the origin point, as to fix an error of rotation of the image. In the previous episode, with the hitbox associated with the sword, when flipping we were basically changing the position of the hitbox to the right or the left of the character. In this case, we'll see another way to do it, that it is basically to flip the sprite. For this to work, we need to have the center of the sprite moved to the bottom right corner of the sprite, as we have just done. When flipping the sprite, it will flip around this center and face the opposite direction while keeping the same range of detection. Flip the enemy vision sprite in the same actions where we are currently flipping the player sprite and in the action associated with the beginning of the scene. Adjust the order of the flips depending on the direction of your own sprite until you have the right flipping order. Run the game to see if it is working correctly. And the answer is yes. We can see the detection box moving and flipping to be always in the front of the skeleton enemy. Time now to implement the detection logic and trigger the attack behavior. In the Animated Enemies Management event sheet, let's add a new event, where in the condition we are going to test if the enemy vision's detection box is colliding with the player's hitbox, and if it is not yet attacking, that we can check by inspecting if the attack animation is currently being played. If both conditions are met, then we can attack the player and trigger the attack animation in the skeleton enemy. Once the attack animation is launched, we need to be able to perform damage to the player, so we will need some hitbox or some collider that will detect if the player was hit by the attack. In the previous episode, the player was continuously dragging in from him the hitbox, but was only able to apply damage if enabled after the impact frame was reached. Now, we will explore another possibility to implement the damage. Instead of dragging the hitbox, we will be creating it in the frame where the impact is supposed to occur, and we will delete it once the frames where damage can be done have passed. To implement it, we need to create a hitbox at the right position, and that we have already defined in the skeleton sprites by defining an image point named hitbox. But, we have not yet created the hitbox, so, let's do it now. For that, create a new sprite object, and name it skeleton weapon hitbox. Add an animation and with Piskel create a placeholder for it. In our case, we are going to use the purple color and later we'll draw an HB to depict it that it is a hitbox. Let's add a new event and let's check if skeleton attack animation is being played. If is, then let's create a sub-event, where we are going to test if the current frame being played is frame number 8. If it is the case, then this means that we can apply damage to the player. So let's create the skeleton weapon hitbox at the sprite image point defined. In the video there is an error as we are using animated enemy when it should have been skeleton enemy, which is the object that actually holds the animations and the information about the image points created. Let's copy and paste the event, and let's modify the newest event condition where we have an equal to 8, to include a bigger or equal than 9. For the action, let's delete the object. Let's add a couple of checks more. First one, on the player detection, let's add a new condition to check if the current animation has ended before playing the attack animation. And in the action itself, let's add a timer cooldown to be able to implement later on a limit to the number of hits that can be done by the enemy. Let's copy the event where we are testing if the attack animation has finished and paste it as a condition in the set of events where we are testing the current frame of animation. Let's copy the event that detects the collision with the player and paste it below. In the two inverted conditions, where we are testing if the current animation is an attack and that it has not yet finished, let's remove the invert condition from both of them. Change the animation to be set from attack to idle. We are basically checking that if the skeleton is attacking and has finished the attack, to go to idle. Let's run the game to see what it is doing. Okay, once it gets in range of the player, the enemy stops and attacks the player, but the hitbox is not created at the right place. This is because of the error that was mentioned before, where we were using the image point coordinates from the group and not from the skeleton sprite where the animation is played and where the image points were defined. So, if you have not yet solved it in the previous action, let's modify it now to be taken as a reference from the skeleton enemy sprite. Let's check again. Every seems to be running correctly. We could fine-tune the place where the hitbox is created or make it larger in case we want a broader area of impact. But, for now it is more than enough. Let's actually make the damage happening. Before going actually into decreasing the life of the player, we are going to have some fun by implementing the hit animation and some knockback, which we are going to half implement, because we would have to take into consideration the direction of the strike, but that in our case, we will just send the player always back in the same direction. For that, let's go to the main events sheet and add a new event. In the condition, check if the skeleton weapon hitbox is in collision with the player hitbox. If it is the case, then add a force on the X and Y axis to move the player back. The larger the numbers used, the faster and the more the player will be pushed backward. Change the animation to be the hit one. In the scene view, select the player hitbox, and click in the left pane in the instance variables options, and then in the edit objects variable and create a new variable named life. Set the initial value to be 10. Once created, let's go back to the damage event, and after the change of animation, let's decrease the value of the object variable life by 1. Once the life value is down to 0, we need to end the life of the player. So, let's look for the place where the player is being killed when touching any enemy. In the condition, let's add an OR operator, and then add the new condition, which will be if the player life variable is less or equal to 0. To avoid having too much damage happening in one blow, add a trigger once condition to the event where the damage is happening. Let's check it is running as it should. It is running, but when dead, the respawn of the player is not working anymore. This is because we are not resetting the life back to 10 when respawning the player. So let's add the action to the respawn event. Let's run again. And The player is correctly respawned. Now, let's do the same thing for the enemy has to be able to inflict damage. We will add a life variable to the physic enemy, and in this case, we will set its initial value to 2. In the animated enemies management event sheet, let's add the code to implement the damage to the enemy. In the event, where we are destroying the enemy, let's add a new condition, where we will be checking on if the life variable is less or equal to 0, before actually killing the enemy. Let's copy and paste the event, to make the damage event. The first thing that we will do is to play the hit animation. Let's remove the remaining actions. Let's change the score sub-event to be 5. Let's add a knockback 2 to the enemy. In this case, we will try another way to calculate the direction of the movement, by using the angle property of the enemy platformer character. Add a force to the physic enemy. In this case, the direction of the force will be based on the angle of the skeleton, inverted to make it move backward. For the speed, let's use the value 50. You can adjust it to whatever suits your case the best. We also need to subtract from the enemy life variable a unit of 1 for each strike received from the player hitbox. Now, let's make it more interesting by adding some sound and visual effects. For the sound effects, we can generate them from the online tool bfxr.net. Choose the sounds that suits the best your game. Save the audio effects. To play the files, from the damage events for both the player and the enemy, add a new action to play music file. Select for each case the sounds that you have generated. For the visual effects, create a new particle system object, and configure it as to launch a couple of particles. Then in each damage event, add an action to create a new object based on the particle system created. You can use the same for both the player and the enemy. In our case we have created one different for each character. Once finished, let's check the final result. We hope that you have liked this video. If it has been the case, consider subscribing, giving a like, and clicking on the notification button. If you have any questions, problems, or comments, don't hesitate in putting a comment and we will answer as fast as we could. See you in the next video, game developers.